Now we'll look at integration by substitution when we're using definite integrals. Now remember, we don't need to add c. It doesn't hurt if you do, but you'll be putting plus c inside your big square brackets, and you'll end up with a plus c and a minus c, so there's just no need to do it. Now the procedure is exactly the same as for indefinite integrals, except you have to change the upper and the lower bounds at the start so that they're in terms of your new variable. So that's one extra step to do, and it's easy to forget that, so this is a real red flag. You need to remember to do this. But on the other hand, it's a little bit easier at the end. There's no need to use substitution to ever go back to the original variable. So once you've got some x dx thing in terms of u du or theta d theta or something like that, you can sub your new upper and lower bounds in, and the answer will come out as some kind of constant. Now this example has the same integrand and the same substitution as we used in the last example of the last video, but this time it's a definite integral, so there's that extra step. So first thing to do is to integrate your substitution. So I'm thinking here du dx equals -1, and so I can write -1, and then instead of writing the dx down here, I can just put it beside it. Next, we need to think about how that relates to what we've got here. We don't have a negative in our integral, but we can put one in and adjust for it. And we can then reason that this part here will be the u, this part here will be the du, but then we need this part here. So we need to rearrange this and say x is equal to 1 minus u. So we've already done these steps before. This part is going to be 1 minus u, just for the x. The negative and the dx is going to be our du, and this part here is going to be u to the power of a half. Now what we haven't changed yet is our bounds. So an extra step here, we need to say when x equals 0 and when x equals 1. Now 0 is my lower bound, x is my upper bound, so I need to put those now in terms of u. So when x equals 0, y is 1, and when x is 1, y is 0. Now make sure you get these the right way round. If the lower bound here is x equals 0, then the lower bound is u equals 1. And the upper bound was x equals 1, so our new upper bound is u equals 0. Don't be tempted to put them the other way around just because you're thinking you need the bigger number on top. Remember that we can run integrals in a reverse direction, it just makes them negative. But we've got a negative sitting out the front here anyway. So you've got two choices at this point. If you've got a negative out the front and you're running your integral in a reverse direction, if you wanted to, you could actually write this around the other way and take the negative off. That's just a step you could do. If you keep the negative there and run it in a reverse direction, it means you'll get a negative answer. It'll come out the same. I'm going to switch it and get rid of the negative in this one because it looks like it will just make my life easier. Now I need to tidy up my integrand. So I've got u to the half minus u to the 3 halves du. And now I need to use my square brackets, integrate this by raising the power by 1, dividing by the new power, or multiplying by its reciprocal, and the same with the other one, so I'll have 5 halves multiplied by 2/5, and then my bounds are now around this way. And then subbing in, I've got 1 here, so this 1 raised to the power of anything is just 1, so this is just going to be 2/3 minus 2/5 minus bracket 0 minus 0, so I don't need to worry about that. And I end up with 4/15. Okay, this question's got some trig involved. So my first step is to find du dx and think du dx, and if I differentiate this I get negative sine x, but where I would have put the dx down here, I can now just write it over there in one step. Now have a look at how that compares with my question. This takes care of the dx part and the sine x part, and it will take care of a negative if I have one. Now I don't have one, but we can put one in and put a fixed factor of a negative out the front. The other thing we can do over here to make our lives easier is we could bring this 2 out the front like this instead of having it in here. That way it's not in the integral and we don't have to account for it, it's out of the way. So now I've taken care of negative sine x dx. All of that is just du. So I've got my -2 out the front, and I've got my u to the power of 6, and I've got my du. Now just checking, these parts here are the du, and this part is u to the power of 6. and I've got my -2 out here as my fixed factor. Now I need to change my bounds. So being careful with this one, if x is 0, then the cos of 0 is 1. So u will be 1. So where we had 0, it now needs to be 1. And change them one at a time so that you're careful not to mix them up. And when x is pi, the cos of pi would be -1. So u will be -1. So that's going up here. Now, you can see here that we're running an integral backwards again. This seems to happen quite often. So if you're running it backwards and you've got a negative out here, you can reverse the two at the same time. So that means that we could, on the next step, say that we're just doing 2 from -1 up to 1 if we want to. Now, that is not essential. We did it in the last example. This time, let's actually just leave the negative in there and see how it plays out so that you can see that it makes no difference, really. Now, this is pretty simple to integrate with respect to u. We just need u to the power of 7 over 7. And we've got our bounds here. They're still round the wrong way, but that's totally fine. Now we need to be careful that this -2 is multiplied by both of the terms that we're going to get here. So when we sub -1 in here, -1 to an odd power is going to be -1. So we've got -1/7 minus, subbing in the 1, we get 1/7. So -1/7 minus another 7th, we've got -2/7 multiplied by -2, and we're going to get 4/7 there. Now, if we'd done it the other way around, and we'd said that we've got 2, and we would have had our bounds around this way, then we would have got 2 1/7 minus -1/7. And I think you can see there that we'll get the exact same result. Now, when you're doing questions like this, it's really handy, I think, to have your reference sheet beside you so that when you're doing this step here, obviously these ones were easy, but if you've got to differentiate something that's a little bit tricky, take your time with it. It might be that you actually need to use the product rule over here, or that you might need to take some time rearranging x in terms of u. This one didn't require it, but if we did need to rearrange this so that we had x in terms of u, would we be able to do it? Yeah, we'd say that the inverse cos of u is equal to x. Now, there might be times that you need to rearrange depending on what you've got in your integrand. So the go with these sorts of questions is to just be flexible. Think about what you've got, compare it to what you have in your ingredients, look at what you need to throw in, and be prepared to rearrange something to suit the question that you've got.